Hello, and welcome to EyeOpener, powered by Siemens. On today's episode, I'm delighted to be joined by Johnathan Bonner, Head of Solution Engineering at Siemens, where we are going to be discussing the topic around predictive maintenance and the need for hardware. So, big welcome to Johnathan. If you could start off by introducing yourself, that would be great.
Thank you very much. Yes, so as you mentioned, I'm the Head of Solution Engineering. And really, what that means for Sensei, as predictive maintenance, is before a project starts, we need to have a very good understanding of the setup, maintenance practices, infrastructure, the data, the assets that we're going to use for the project. And all of these need to be very well scoped out beforehand. So myself and the rest of my team, we're responsible for making sure that a project is reasonably successful before it even starts.
Perfect. Well, great. Really great to have you on today's episode. So I guess let's get straight into the topic around predictive maintenance and the need for data.
Yeah, so to make predictive maintenance work, we really are looking for three forms of data. The first is condition monitoring data, such as pressure, current, torque, vibration, temperature, speed, flow, and a full range of others. Along with that, we're looking for operational or contextual information. So if you have a different product running through the same packaging line at different parts of the week, we need that contextual information to give an indication of normal operating change. And the third form is maintenance data. So maintenance data is used not only to give an indication or logical indication of why something has changed after repair, but it also allows the application to build patterns and form information based around what maintenance was carried out.
And then just moving into, so I know we're focused on this topic of the need for data, right? So if you could maybe go into that in a little bit more detail, because I understand that when it comes to individuals wanting to use predictive maintenance, they may already have existing infrastructure.
And this is one of the key factors that we have to scope out before the project starts is what do you have existing already? So a typical infrastructure that we would see is on any industrial site, you'll have PLCs, inverters, drives that are all responsible for automating the process, automating your procedures and so on. There is data that is naturally within those. You will be able to get speed and pressure and current and so on from these devices. In some cases, you'll have edge processing devices already installed. And utilizing the existing data within a site is extremely important because it's a massive win for no extra cost. If we can get to the existing data that's in a good format and a good structure for predictive maintenance, we can start to find value immediately and bring value to a project immediately without having to install additional hardware, additional time, additional costs, additional resources to do all of this.
Okay, perfect. And from your perspective, Johnathan, what would you say are different types of hardware that you've seen? Maybe going into that in a bit more detail, just around.
So typically within an environment, what will already be there is PLCs, drives, inverters. You may have some additional sensing that's been installed. Quite often nowadays, OEMs are installing sensing in their machines already to capture relevant bits of information. Okay. Yeah.
Okay. So, Johnathan, from your perspective, what are the benefits of using existing infrastructure?
There are a number of benefits. Because if you think about having to install something, you have to stop your process, stop your machines. You need to have the skilled resources to be able to install. There's loss in productions and a full range of other stoppages that you will incur if you have to install. So when you're using an existing infrastructure, theoretically, the amount of work to access the data that it holds is a lot less. You have a lot less stoppages and downtimes. You don't need as many specialists to do the installation. And there's generally a wealth of useful information already there. So if we look at some of our clients within automotive, they've been able to run entire successful projects without installing any new sensing. The information required for predictive maintenance was already there and has shown great success. If we look at industries like metal and mining, the amount of data that already exists in these environments is huge. And it's just about being able to leverage that for use in predictive maintenance. There are a full range of industries that have aged equipment, older infrastructures, but still have a wealth of useful information and data to use. So really it's around cost saving, time to implementation, but also just being able to run full projects.
I think that's an interesting point you made, because when it does come to existing infrastructure, people don't realize how much information and useful data they've got. So it's just having that, that specialist coming in, especially within predictive maintenance, to assist and say, well, hey, you've got this data. We could help you to look at it in further detail and then optimize and use additional hardware.
Yeah, absolutely. And we've got a very structured process on how we find out what is the right data. So first, we would want to understand the operation or the assets that we're monitoring. How are they operating? Is there operational complexity and interdependency between different assets in different areas? We then want to find out how does these assets fail, and what are the failure modes unique to your environment, how you're using these assets. And from there, we can assess the data that you already have. So at this point, there's a tie-in between data and known failure modes. How is this data relate to known failure? And at the end of the day, in some cases, there isn't enough data to have 100% coverage, but it's all right because you have 85% coverage or something like that. So you can still have a huge amount of cover from predictive maintenance with your existing data. And we run through this process of investigating that for you, and then make the decision on whether or not additional hardware is required.
Okay. And typically, how long does that process take?
Oh, that's a how long is a piece of string question. Typically, that can be covered with 1 or 2 days on site. So an actual site assessment from the team. We'll go in, have a walk around, understand the processes, the assets, get a list of what data is available for these assets. And then to make the comparison between data and failure modes could take a few days. So really, you could be looking at a week turnaround for that. In other cases where we may not have representation in that area, so we are relying for the sites to give us the information over email, whatever it may be. That can take a little bit longer. Everyone's busy. Everyone's got a day job, so getting feedback from the site can be a little bit troublesome. But yeah, you're not looking at huge amounts of time, especially for the initial assessments. What we're looking for before a project starts is not to have everything 100% nailed down. We're looking at do you have the right information that would be useful? And then once the project starts, we can do proper investigations on exactly what kind of coverage you get.
Okay. Perfect. No, that's good to understand and know. So I guess I know we touched into this, topic around benefits of existing infrastructure. And I guess with regards to anything, there's always going to be the cons, right? So it'll be good to understand what are the problems that could potentially occur with existing infrastructure.
So if we look at the levels of existing infrastructure, you've got the hardware, PLCs, drives, inverters, as I've mentioned. In some cases, a factory will have a factory historian, an SQL database. In other cases, they may be using a SCADA system. And if you're having different layers with all good information inside of them, you now need to get them to talk to each other or have a centralized way of getting that data through to the cloud. So when you're looking at all of these different layers, they have different communication protocols, different ways of communicating, different ways of sending data outwards. So you always need to assess how are we going to get the data? What communication protocol is this system using? Do we have something in common that could, a data acquisition device, for example, that can pull the data out to centralize it? So there is troubles with those type of communications. The second being, not everything is going to be programmed for predictive maintenance. So yes, a client may have a PLC used for automation, but that doesn't mean that it's naturally acquiring the right type of data. So we need to make sure that it is acquiring the right type of data. If not, there is work to be done around reprogramming this. typically, clients don't want to let you anywhere near to the automation system, because as soon as you start messing around with it, it could fail, and you could then have lasting production issues from there. Also, data quality may be an issue. When actually assessing what the time series data looks like, you may have things that are stored at super high frequency rates and other things that are stored at very low frequency. Typically, what we're looking for is a sample that's, well, samples that are happening every second. Okay. Anything higher than that is extremely noisy. So with an existing infrastructure where you have super high sampling rates of data, you need to downsample, you need to aggregate, you need to process the data. And this all takes either rework on the existing infrastructure or an additional device to do. So yeah, there may be data available, but it can be hard to get to.
Okay, no, that makes sense. That takes me to the second part, really, which is more focused around the need to install additional hardware. So I guess that touches into what you mentioned. There could be issues with the data quality. What they have currently at the moment is not collecting data. And I guess that's where, you know, we would then come in to install additional hardware to support.
So again, we would follow the same process of understand the asset, understand its operational complexity, understand how it fails, and understand what is available. From there, we can then assess the gaps. So if you're looking to monitor bearings, for example, and there are billions upon billions upon billions of bearings out there, the most effective way to do that, or one of the most effective ways, is through vibration. But you need to assess, is vibration needed? Yes. Understand the operational complexity to say what type of vibration is needed, because not all vibration is the same. In some cases, you can have very simple RMS vibration readings. In other cases, you can do full FFT analysis, look at the spectrums, the waveforms, and be very specific around the failure mode. Okay. So when assessing, you need to see what is the type of additional hardware that's required. So what is your output? What is the data that's going to come from it? And is there a need for it? Yes. Okay. Then you can start to assess the types of sensing, the different suppliers that there are, the outputs of it. What does it take for this system to function? Because really you have 4 different types of sensing in the sense of its structure. So one type of sensing is your sensor. You'll have a data acquisition. There will be a cloud replication service. Typically, this will be the client's cloud. And then we would connect that through to the Senseye cloud. The next one is you have your sensor, a gateway, which pushes directly through to the Senseye cloud. The third form is your sensor, data acquisition, gateway, cloud. And then the fourth is dumb sensing, which is typically a 4 to 20 milliamp output, which will go into an existing infrastructure route. So you need to think of what is going to be best suited for your environment. Then again, the suppliers, find out the costs. Is the cost to benefit ratio there? Does that make sense? And then look at installing that. So there is quite a process to defining the right solution for the right application for the right client.
So, Johnathan, from your perspective, what are the benefits of installing additional hardware?
Well, it is mainly to cover the gaps from what you have existing to what you need. And so when you're looking at a project, you're scoping out a project, there has to be, as I've mentioned, the cost versus benefit ratio. That has to make sense. And when you are installing additional hardware, you can really make sure that you have the right data, the right quality, the right sampling, the right measures. Everything falls in place because you are deciding on what it is you're installing. So for example, we had a client that makes cardboard boxes, and we, for whatever reason, weren't allowed to go into their existing infrastructure. We weren't allowed to get any of their existing data. So we had to help them scope out the entire process, the entire stack, the full stack solution from sensor all the way through to Senseye. This meant that we had to find the right type of sensors for the right type of machines. Some were basic bearings just on rollers. Others were complicated motor gearbox combinations, couplings. So different sensing requirements for different assets. We also had to help assess the right automation layer because we used PLCs to take in the raw vibration signals, process them correctly, and push it through to the cloud. So in this case, we had a direct connection to an OT layer through to the cloud, but it was dedicated for vibration. All of this is extremely costly. So the entire project with installation costs, the cost for the hardware, the cabling, and all of the cableways that had to be created brand new, we're looking at hundreds of thousands of euros. But the benefit for them was they had full coverage of an entire cardboard corrugator line. They could understand exactly, long time before anything happened, what was going to fail, and they could plan it in. And I believed they achieved an ROI with that in 4 months. So in that case, by being able to reduce their unplanned events, giving them planning time, an early indication of asset degradation, they were able to change their maintenance practices and get value almost immediately. When you are looking at the payback for hardware in a project, typically customers would look for a payback within 5 years. So there's a separation between your initial hardware investment and then, let's say, the project investment. And payback should be, as I said, 5 years, in this case, 4 months. It absolutely made sense for them. And we were able to customize and tailor everything as it should be. We were getting fantastic data, and we've been able to scale this out to multiple facilities.
I think that's a really great point, Johnathan, around having complete transparency in terms of the operation and what's going on. So at least you can understand your assets and you can understand the data, and you've got all of that going on, which helps to...
Yeah, especially when you're looking at an entire production line.
Yeah.
From start to finish, you have full coverage. Because if you're looking only at a portion of the line or only the critical high value assets on a line, that's fine. So it's good to do. But other smaller, insignificant things could still affect your production output. And effectively, in any manufacturing facility, that is what you want. It's the end of the product coming out of the line. So if you have full coverage, you can make sure there aren't any bottlenecks, aren't any small things that still will stop your production line. You can really look at the entire line's worth of reliability rather than just critical components that may or may not fail.
Okay, fine. And what would be examples of those smaller little problems that we may encounter?
So let's say a conveyor, for example. The conveyor's purpose is to move box from point A to point B. It's not particularly high cost. It doesn't have any fancy operating states or any operational change. But it is also a key point of the transportation of the product. So before it can get off the line, before it's a finished product, it's been transported from here to there. And if that goes down, it doesn't matter how fancy or how well everything else is performing and operating, there is your bottleneck. This goes down, you stop the production. So now you need to come in, first do a failure analysis, find out what's happened, why has it failed, what is the reasoning. Then go find, do we have the spares in stock? Can we safely repair this asset now? Do we need work permits? So there's a full range of processes in place that you need to do before you can fix this. Whereas if you had good indication that something was changing, something was degrading, you could have planned in this repair long before it happened. Yeah. So you can make sure that you have the right spares, that you have the right skill sets on site to do this work, that it's you do the repair at a time when production allows. So whether that's a weekend shut or your planned maintenance interval that you have, you can really plan in this to have the least impact and be done at the best time.
Okay, I understand. So I guess from a Senseye predictive maintenance perspective, how can the software help support the need for data?
Well, within the application itself, we have this very useful functionality called Derived measures. It allows you to take two or more inputs and through whatever mathematical equation you can imagine to apply, you can then create an output. So you derive a measure or a virtual sensor. This is extremely useful if we look at the existing infrastructure, for example, if we're getting data from an existing infrastructure. You may have two measures, a motor current and speed. And just as measures themselves, yes, they're useful. But now we can start to build relationships between them. We can start to apply and derive further measures from this. If we look at pressures, an input and an output pressure, for example, maybe we want to know the difference between your delta. So we can derive that as a measure and monitor the difference between the two inputted measures. So the application's got that functionality within itself. But as a company, we are very much geared to guide our clients to the right type of hardware. So not only do myself and my team assist with this, we've got all of our delivery engineers are highly skilled and very, very experienced. They understand what other customers have used and other clients have used. They have their own real world experience. So we very much guide our clients through the process of identifying what data is required, and then we can help them assess what hardware is then going to be installed. At the end of the day, for the Sensei Predictive Maintenance application, the hardware or where the data comes from is irrelevant. It's the quality of data. And that for us is the key factor that we always try and work towards, making sure we have good quality data, regardless of where it comes from.
Okay, brilliant. And I guess it is a combination between the two, isn't it? The people and the actual software that we have, which can help support. And I think when it comes to predictive maintenance and looking into existing infrastructure and additional hardware, I think it's that wealth of knowledge, isn't it? Having the right people there to support you, who can assist with what's going wrong, how we can avoid the failure. You know, if there is need for additional hardware to be installed, then you've got that support available.
Yeah, absolutely. So if I look at my experience, I spent 10 years, just over 10 years, as a condition monitoring engineer. So I'm certified and experienced in vibration analysis, oil and fuel analysis, thermography, and ultrasound. So when I go into an industrial environment, because I've worked in almost every industrial, I've worked in almost every industrial sector around. I'm familiar with the assets. I'm familiar with the processes. I understand what is unique between a motor in a chocolate factory and a motor in an automotive factory. Yeah. And that really does help me assess what type of data is going to be required, and then what type of sensing will be required.
Okay. So it is very much dependent on different industries as well, right?
Yes, every industry has their nuanced differences. You know, it can be quite frustrating at times because someone says, but do you have a use case? Do you have success cases from my industry? And we go, but a motor is a motor is a motor. Yeah. But there are differences. There are differences in the way that these motors will be used, the way that they're going to be run, what it is that they're driving, the operational changes that they have. Some industries, you'll have lines that just chug on at a steady state, and others that have constant changing speed. Yeah. They're being worked in different ways. So, yes, every industry is unique, but there's a lot of commonality between a motor and a motor.
Yeah, exactly. How would you decide whether or not to invest into hardware?
So I was recently asked to scope out a sensing solution for slow rotating equipment. Now, slow rotating equipment is quite hard to monitor because normal vibration doesn't cover that. A vibration works off of, if you look at the frequency ranges, it starts really from about 10 hertz upwards, and you're looking at rotations of, let's say, 300 RPM. That's your starting speed. This is, well, the application I was asked to scope out for was 30 RPM. Okay. So very slow speed. Traditional vibration monitoring wasn't going to cut it. So I eventually scoped out a solution, found sensing, found a company, found the right sensing for it. And to cover one machine, so we would have 8 sensors, your data acquisition device, and whatever mechanism was required, like a gateway to push data through to the cloud, we're looking at tens of thousands of dollars. So it's extremely expensive. So really for the client, that is not, the cost versus benefit ratio is not there. However, if you do have a machine that is worth millions at a slow rotating speed, the impact of downtime to your production and to your output is extremely high, then of course that makes sense. It's a fraction of the cost it would be if it were to go down. But in other cases, people will have spares and components available. They may have an entire unit as spare or redundant that they could quickly swap out. The impact to production isn't there. So you really need to assess, what is the value of this? Does it make sense for me to invest this amount of money on this? What is the negative outcome if I didn't have it? And is there any other hardware solution that could cover this? Maybe there's a cheaper supplier out there that has exactly the same outputs, exactly the same hardware, exactly the same quality standards, and so on. So yeah, you really need to think around, what is my benefit for this?
Yeah, exactly. And I guess it can be, cost, from a cost implication perspective, it can be very expensive. But I guess it really depends, like you mentioned, on the value and the focus and what it brings to the table, right? And I guess inevitably when it comes to, the need for data, I think a lot of individuals really just want that assistance to help, for them to understand what they currently have at the moment, and then to have a specialist who can then turn around and say, well, this is what you have, but this would be better to help this process. So it's a long-term goal and focus.
Yeah, absolutely. And we are working with one of the other business units within Siemens, and they are working with a client who is redoing the infrastructure, complete redo of the automation, new assets, new lines, new everything. And they're interested in Sensei, but they're not there yet. So they're waiting for this upgrade. Now, what we're doing is we're working with this other business unit to make sure that in their investigation, the proposals that they submit, as well as the execution of this, the upgrade for the infrastructure and automation, that they are future-proofing it for predictive maintenance. That when they're installing, they, yes, will get the necessary measures through PLCs, but that they're also making the useful data for us available for a later stage. So really, really different business departments working together as specialists to make sure that the client is not only happy with their immediate need, but that they are future-proofed for predictive maintenance at a later stage. And I can really see that level of speciality, that level of service, that the assistance that we're giving to the client is greatly appreciated.
So in terms of current trends, because I guess in regards to anything, there's always trends which appear. So from a client perspective, is there anything that you've seen recently in the last couple months which has been a focus for what they're looking to install and what they would like?
Yeah, so I think as technology gets better and better on a daily rate now, there are new technologies that people want, that they want to test out for whatever reason. So typically it's previously we would have had just wired sensors. So a sensor that was wired, the wiring would be your data path, but it also could be supplying power to the sensor itself. With technology now, Bluetooth sensing and wireless Bluetooth sensing is extremely popular. So everything, you place the sensor on, it has a certain amount of battery life, 2 to 5 years roughly, depending on your sampling frequency rates. And that will go to data acquisition device, and that will then get pushed to the cloud. So those are particularly useful when you don't want to have the wiring costs and the additional installation costs. So very useful. Downside of them is you have to change the batteries ever so often. Also, depending on the size of the environment you want to put sensing on, depending on what you have in the way, you have to think around how far away can my sensor be from the data acquisition? Is there something in the way that's blocking that data path? There's also technologies such as mesh technologies where every sensor acts as a data acquisition device and a transmission path. So you can actually extend the range between your gateway and the sensors. You can mesh them all together in a network and use that as a path through. There's also technologies like LoRaWAN that are out there. So yeah, I would definitely say there's been a lot of focus on wireless technology and the increase in that, and it is getting very good. Yeah. But for steady, reliable data acquisition, wired is still, it is still a way to go for now. But I definitely think the wireless technologies are going to get good. Well, the wireless technologies are going to get good enough very soon, where it's just going to be the way to go because of the ease of installation, reduced cost, and their reliability.
Exactly. And that's synchronized with the way technology operates now. Even when it comes from a wireless Bluetooth perspective, we use that in our day-to-day life, don't we? So when it comes to predictive maintenance, I guess the need to want to have wireless sensors and installation to be wireless and Bluetooth, there seems to be much more of an increasing demand, like you mentioned. So.
Absolutely, and I think any project manager will want to have the state-of-the-art solution installed.
Yeah.
People want to use technology for the betterment of their lives, and it's completely natural to want to be, at the forefront with the trends that are going on.
Yeah.
But again, you need to always think about what is your use case here. What am I trying to achieve? Start with the desired outcome, and work your way back to find out what type of technology is going to be useful. What is it you need to use?
Yeah, I think it's just going back to what you're looking to achieve and asking yourself those questions and seeing if it's actually going to be beneficial and the right thing to do when it comes to wanting to install additional hardware. So, Johnathan, on our previous episode, Christina asked a question for our next guest on the show. And that question is around whether or not you think artificial intelligence should be regulated.
It seems like a very simple question, but it's actually extremely tough. I think I, like most people, have had the benefit of using ChatGPT to give me a structure, give me the baseline for something I didn't know how to do. But I also see the difficulties that, let's say, lecturers or teachers are having, where a huge portion, or at least they believe a huge portion of their students are using AI to generate answers for school. So, it's always tough. There's the ease that AI brings, the ease to your daily life, but there's also the lack of responsibility that gives. So I don't know how, but yes, I believe it should, especially around the educational sectors. I do think that students of all ages, all over the world, need to be responsible for the content that they create. It really shows that they have put the effort, the time, the learning into the subject. Yeah. But I also think it's very useful to learn or be able to do something that you don't particularly know how to do or you're not very good at. As long as you use it in the right way. So yes, I think it should, especially around the educational sectors. Okay. But how that happens, who knows?
That's a really great answer. Thank you. And then I guess from your perspective, if you could ask our next guest on the show a question, what would it be?
How do they think technology and AI is being used to unite the world from its regions? Different countries, different geographic locations. Is it being used to unite or separate?
Very interesting question. Perfect. Well, thank you very much, Johnathan, for joining me on today's episode. Really enjoyed your insights into this whole topic around predictive maintenance and the need for data. So yeah, thank you again.
Thank you.
A big thank you to our audience for tuning in on today's episode. Please like and subscribe to our channel and stay tuned for the next one in the series. Thank you.